Okay, this will be a review of 6.3. So 6.3 was composition functions and add, subtract, multiply, divide, and then domain. And I'm really going to stress domain is a pretty big part of your test, so make sure that you do understand it. So pause the video and see if you can do all of these. Okay, so the first one says take f plus g. So I'm going to take 5x to the 3 halves plus a negative 2x to the 3 halves. And yes, I can add them because their bases and exponents are alike. So 5 minus 2 is 3x to the 3 halves. And then I'm going to come down here to part E while I'm here and talk about the domain. So x to the 3 halves. Now remember, you should look at your unsimplified. Well, they're both square roots. And square roots have to be positive. So I have no denominator that I have to worry about. I do have an even exponent that I have to worry about. So square roots have to be positive. So the domain for part A is all real numbers that are greater than or equal to 0, because you can square root 0. Then B says to subtract them, so it's the same work, of course, except you're subtracting a negative 2. Let me write that out. So that's really plus a positive, so that's going to be 7x to the 3 halves, and its domain is going to be the same, so I won't rewrite that, but the same domain, right, because I have the square root again, so same explanation. Part C, I'm going to multiply those together, so 5x to the 3 halves times negative 2x to the 3 halves. So 5 times negative 2 is negative 10. X times x means I'm going to add those exponents, so 3 halves plus 3 halves is 6 halves. Actually, let me just, 3 halves is 3. 6 halves, excuse me, is 3. And now this one's tricky because x cubed, you can cube anything, so your domain for the final answer would be all real numbers, but remember your domain goes back to the unsimplified. So again, you have square roots, so your domain is everything greater than 0. And last but not least, I'm going to divide these. So 5 divided by negative 2 is still negative 5 halves. And then when you have like bases, you subtract the exponents. Well, 3 halves minus 3 halves is 0, and x to the 0 would be 1. So I just have negative 5 halves. Now again, here, your x is wiped out, but down, you want to look at your unsimplified. So this one's a little trickier because you have a square root, which has to be positive real numbers, but it's also in the denominator of a fraction, which means it can't equal 0. So D actually has a little more restriction. All real numbers that are greater than 0 but not equal to 0, because if it equaled 0 I'd be dividing by 0, which I cannot, so be careful with that. Okay, compositions. Remember, compositions is really just a substitution game. So if you have f of x and g of x, and it says to do f of g of x, you're going to take f of x, which is 6x to the negative first, and then you're going to replace it with g, which is 3x plus 5. Now, a couple things I see all the time is people say, oh, I'm going to distribute that negative 1 power through. You can't distribute a power to a sum quantity or like a subtraction or addition quantity. But this is a negative exponent, so I should flip it. The 6 is not. Technically, that 6 is raised to the first, so that does not flip. 6 stays on top. 3x plus 5 flips down to the bottom. Now, what's your domain? Your domain, okay, so I cannot divide by 0, so whatever this quantity is in my denominator, it can't equal 0. So I'm going to take that denominator and set it equal to 0, because I know it can't equal 0. And then I'm going to subtract 5 and divide by 3. So x cannot equal negative 5/3. So your domain is all real numbers except negative 5/3. And this is your composition function. All right, g of f of x means I'm going to start with 3x plus 5, and then I'm going to replace the x with g, or I'm going to replace the x with f, excuse me. And I can certainly multiply this because there's no power here. So 3 times 6 is 18x to the negative first. And I can't have a negative exponent, so I flip that over the 18. Okay, now again, a couple things to be careful. If this 18 is technically to the first, so it doesn't flip. I can't add 18 plus 5 because the 5 is not over x. They aren't common denominators, so this is as far as I can take it. And then my domain is pretty easy. I can't divide by 0, so x is all real numbers except x can't equal 0. All right, the last one, f of x. So I start with 6x to the negative first, but I replace that x with itself. Okay, now power on a power means I'm going to distribute. So I'm going to distribute that negative first power to the 6 and to the x. So it's 6 to the negative 1 and x to the positive 1. That first 6 is to the positive 1. Well, when you have like bases, you add the exponents. So 1 minus 1 is going to cancel out, so that 6 is going to cancel out. Or if you flipped this one, it'd be 6 over 6, which is 1, right? So that really is just x for the composition. And then the domain, again, very tricky. The domain you would think is all real numbers because that's a nice linear function, but remember to always go to your unsimplified, and you see that you have that negative exponent, which is really, 1 over x. So again, x is all real numbers except x cannot equal 0. So be careful with your domain. Look at the unsimplified quantity. All right, last one then, find f of g of x. So I'm going to start with f of x, which is 5x squared minus 4x. And I'm going to replace the x's with g of x, which is 3x minus 1. Okay, there's a lot going on here, so be real careful with this. So first and foremost, this quantity is being squared, which means I have to FOIL that. So I'm going to take 3x minus 1 times 3x minus 1. So that's going to be 9x squared minus 3x minus another 3x is minus 6x and plus 1. And I'm going to go ahead and distribute this through minus 12x plus 4. Be careful, right? You have a negative to a negative. And then I'm going to go ahead and distribute this 5 through. So 45x squared minus 30x plus 5 minus 12x plus 4. And combine my like terms. So I have 45x squared minus 30, 42x, and plus 5 plus 4 is plus 9. And the domain of that composition, remember to look to your original, unsimplified. So here it was. Well, I didn't have any fractions, I didn't have any roots, and no denominators. So my domain can be all real numbers.